Imagine a world where the encryption that keeps your bank accounts, private messages, and sensitive data secure could be cracked in a matter of seconds. What if I told you that technology capable of breaking today's toughest codes already exists? This is the future we're racing toward, thanks to Shor's algorithm and the power of quantum computing. But before we panic, let's understand how this revolutionary technology actually works. To start, let's talk about qubits. Imagine flipping a coin. It's either heads or tails, right? That's how classical computers work. They can either be 0 or 1, like heads or tails. But in the world of quantum computing, the coin can do something special. It can spin in midair and show both sides at once. This is called superposition, and it's what makes qubits so powerful. They can be both 0 and 1 at the same time, letting quantum computers handle many possibilities at once. Now, let's take a look at the encryption that keeps your data safe. Imagine a combination lock with hundreds of numbers. Classical computers try to unlock it by testing one combination at a time, like turning the dial on a lock. This can take forever. This process works for small locks, but for the huge numbers used in encryption, it could take thousands of years to find the right combination. That's why today's encryption is considered secure. Classical computers simply don't have enough time to crack the code. Here's where things get interesting. Let's look at how encryption works with factors. Think of it like this. You take two secret numbers, let's say 7 and 11, and multiply them together to get 77. This number, 77, is like a lock that protects your data. To unlock the data, you need to know the original numbers, 7 and 11. These are called factors. For small numbers, it's easy to figure this out, but for numbers with hundreds of digits, classical computers struggle to find the factors. This is where Shor's algorithm comes in. Remember that combination lock? Instead of testing one number at a time like classical computers, Shor's algorithm acts like a magnifying glass that finds hidden clues, giving the quantum computer a shortcut. Shor's algorithm takes advantage of quantum computing's ability to explore many possibilities at once. By finding patterns, it can quickly narrow down the possible factors of a huge number, turning a problem that would take years for a classical computer into something solvable in minutes or hours. One of the most widely used encryption systems is called RSA. It works by multiplying two massive prime numbers to create a lock for your data. For a classical computer, finding the two numbers that created the lock could take thousands of years. But with Shor's algorithm running on a quantum computer, it's like having a master key that can break the lock by finding the original numbers in a fraction of the time. This is the game changer. Let's take a deeper look at how Shor's algorithm cracks these big numbers. Instead of guessing factors one by one, Shor's algorithm finds patterns in the number that classical computers can't see. It's like looking at a puzzle and being able to spot the hidden solution instantly. Shor's algorithm uses quantum properties like superposition and entanglement to explore multiple paths at the same time. This allows it to find the hidden factors, the original numbers that were multiplied to create the large encryption key. So what does this mean for the future of encryption? If you enjoyed this analogy-filled explanation, hit that like button and subscribe for more easy breakdowns of complex topics. Let me know in the comments what you'd like me to explain next.